So first I'm going to comment on the growth of my crystals thus far. I'm going to show them in different angles, but this is what we have so far. It's been almost 2 days on the dot. So this is what my crystals look like from underneath. You can see that I have a light above to help show them a little more clearly when I shine it over them. They've grown to cover maybe 30% of the whole surface of the bottom, and they're about 3 to 4 millimeters tall right now. So that's it after 2 days. Now I'm going to talk about the chemistry behind our experiment. And so we began with solid aluminum, and first we wanted to get it into a form that's more easily dissolved. And so what we had to do is essentially put it in 4 molar potassium hydroxide, and what this does is it creates a solution of aluminum hydroxide. After that, what we did was we added sulfuric acid to our aluminum hydroxide solution, which was black at this point. And after adding the 9 molar sulfuric acid, we saw that the aluminum hydroxide, a lot of it precipitated out in the form of a whitish foam that was not easy to see through. Additionally, the sulfuric acid continued acting against the base of the hydroxide, and this caused it to remove the solid hydroxide from the solution to force it to precipitate. And then at that point, we continued to heat it and stir for 10 minutes at 50 degrees Celsius in order to further dissolve and supersaturate our solution. Now we do this chemically because we want our solution to have as much solute in it, because this guarantees us that when it crystallizes, it'll be in its most potent concentration. After that, we rinsed it and filtered it using vacuum filtration and 50-50 ethanol and water just to remove impurities. And at that point, it had turned more from a liquid to a solid, which because we know the solubility of alum, we are able to make a 40 milliliter solution, which would be saturated. And then after that, we just poured it into a vial through a filter to make sure there is no solid in there, and we capped it and waited for it to grow. I would take the similar approach to what we've done here, where we supersaturate a solution, and then we just let it return to normal temperature, and with time, crystals will grow. So essentially, I would follow a similar outline to what we've done, with the exception that we know that sodium chloride is readily dissolvable in water because it is an ionic compound. And so we wouldn't need to go through the process of, for example, what we did with the aluminum where we dissolved it with potassium hydroxide. We wouldn't need to do that because all we'd need to do is just pour the table salt in, heat up the mixture until it's super saturated, meaning we'd see a little bit of crystals at the bottom of, I assume we'd probably be stirring a pot. We'd see some crystals there in the super saturated solution. And what we would do from there is filter it through, make sure there's no excess salt, and then put it in a vial and let it cool and grow. Research I did is actually very interesting. It's how they make sugar crystals, and that process is very similar to what we did, where they dissolve. Once again, we know that sugar is dissolvable in water, and so what one would do is you would once again heat up water and pour in sugar to supersaturate the water solution with sugar. Make sure there's a little bit of crystals at the bottom, because that's how you know you've reached full saturation, and then filter through to make sure there's no excess crystals. We only want what's dissolved in the water. And then after that, many times I'll add food coloring to make it like candy flavored. And after that, once again, you just let it grow in solution. The As the solution cools down, the crystals will grow, and assuming you filtered it properly and fully saturated it, there'll be some really big, clean crystals.